Again we are back with the same chapter, three-dimensional figures, and in this time we are going to study about the second topic of this chapter. So the topic is Euler's relation for three-dimensional figure. The relationship is what? The relationship is that f minus e plus v is equals to 2. This should be satisfied for all the three-dimensional figures. Here f stand for number of faces, e stand for number of edges, v stand for number of vertices. And when you're going to find this value, that is f minus e plus v, it should always be as 2 only, and this should be proved for each and every three-dimensional figure. So let us see for some of the three-dimensional figures. So the first verification of this Euler relation for the figure we are going to do is for cube or cuboid, as we know that the number of faces, edges and vertices for a cube and cuboids are same. So just see how many faces are there. So 1, 2, 3, 4, 5 and 6. So 6 faces are there. Find it out what is the edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 edges are there. So how many vertices are there? So 1, 2, 3, 4, 5, 6, 7, 8. So 8 vertices are there. So that means my f is 6, that is faces, e is 12, that is edges, f v is 8, that is vertices. So what is the relation f minus e plus b? That is 6 minus 12 plus 8. So 6 plus 8 is 14, 14 minus 12, 14 minus 12 is 2. That means for a cuboid or cube, the Euler's relation satisfies. So let us move to the next one, that is a prism. And in a prism, you are going to study about triangular prism. So let us find out how many faces, edges and vertices are there for a triangular prism. So just see the faces. So how many faces are there? So one triangle, two triangles. So that means two triangular faces are there. And the next is, just see, one rectangle, this is another rectangle, and this is the third rectangle. So we have three rectangular faces. So total 5 faces are there. So the next one is find out the edges. So 1, 2, 3, 4, 5, 6, 7, 8, and this is 9. So 9 edges are there. The next is vertices. So 1, 2, 3, 4, 5, 6. So 6 vertices are there. That means my f is 5, faces are 5, edges are 9 and vertices are 6. So f minus e plus v will be equals to 5, this 5 minus 9 plus 6. So 5 plus 6 is 11, 11 minus 9 is 2. So that means for triangular prism also my Euler's relation satisfies. So next one is square. So let us find out how many faces are there. So 1, this 2. Take the other color. This one is 3, this is 4, this is 5 and the front one is 6. So we have two squares, the upper and the lower one, and the 4 rectangles, all the 4 sides. So total is 6. So next thing, let us find out the edges. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So 12 edges are. So next is vertices. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 vertices are there. That means the faces are 6, edges are 12, vertices are 8. So again we are going to use the same formula, that is f minus e plus v. So f is 6, e is 12 and v is 8. So 6 and 8 will be added. 6, 8 is 14, 14 minus 12 is 2. Again that means for a square prism also my Euler's relation satisfies. The next one is pentagonal prism. Again, I told you, in case of prism, the base or the identical faces will decide the name. So here, what is the name? The name is pentagon. That means my two identical faces will be two pentagons. So that means I have two pentagon shapes or two pentagon faces, and each pentagon sides will be connected with a rectangle. So just see, this side is connected with one rectangle, this is another, this is the third rectangle, this is the fourth rectangle, and this is the fifth rectangle. So 5 rectangles. So total 5 plus 2 is 7. So we have 7 faces. The next one is edges. So how many edges we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 edges, right? The next one is vertices. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 vertices. So that means my face, that is F is 5, sorry, S is 7, edges, that is E is 15, vertices, that is V is 5. So F minus E plus V will be equals to 7 minus 15 plus 10. So 10 and 7 is 17. 17 minus 15 is 2. Again with the same figure, I wanted to show you something. Just have a look here. Okay. Just see. Since we are talking about a pentagon, that means we know that we will have a base, and on the top will be a pentagon like this, and these two will be a pentagon, and each of the sides of the pentagon, of the two pentagons, will be connected with the rectangles. As you can see, these two sides will be connected with one rectangle, then again these two sides are connected with the second rectangle, these two sides are connected with the third rectangle, these two sides are connected with the fourth rectangle, and these two sides are connected with the fifth rectangle. So that means we have 5 rectangles in that way. In the same way, you can see here, for the square prism we have two squares, 1 and 2. Now let us see how you are getting 4 rectangles. One base, and this is one side of the square is connected with one rectangle. This is the second side of the two rectangles are connected with the second rectangle. The third sides of the square connected with the third rectangle, and the fourth side of the square is connected with the fourth rectangle. So in that way we can see that if two squares are there, we have 4 rectangles. How 4 rectangles? Because each of the 4 sides is connecting with one rectangles. So in the same way, when you have a right prism and the number of sides, the base is a polygon with n sides, in that way you can say that how many faces are there. So two polygons of n side, because the base and the top will be the polygon, and here the sides are given an n, and each of the n sides, because since here we have, see, for the square we have 4 sides, so all the 4 sides from the base and top are connecting, right? So since here we have n sides, so all the n sides will form n rectangles. So that means we have n rectangles. So the number of faces will be n plus 2. In the same way, let us find out the edges. Sorry, edges. So here, just see how we are getting 15 edges. Let us find it out first. So just see, one pentagon is having 5 sides. This pentagon is having also 5 sides, and each of these vertex is connected with the other one. So 1, 2, 3, 4, 5. So that means the 5 here edges and 5 for this pentagon, and each are connecting with 5. So 5 is the edges of the rectangles. So in that way we can see for the for squares also. Just see, 1, 1, 2, 3, 4, 4 for this square, 4 for this square, and 1, 2, 3, 4. So 4. So 3 times 4 we have. So we can write 3 times 4 means 4 multiply with 3. In the same way, in that one for the pentagonal, it will be 5 times 3, right? 5 on the top, 5 on the below, and 5 is in the middle. Same thing if you have in place of 4, if you have n, so it will be 3 times n or n multiply 3. That's what we have taken here. You can see this is 3n. Now let us find out how we are finding out the vertices. Just see, have a look in this figure only. N is 10. How we are getting n as 10? 5 vertex for the this bottom pentagon and 5 for the top. We are getting 10 vertices, right? In the same way you can see for the square also. For the square also 4, 1, 2, 3, 4 for the bottom vertices and 4 to the top of the prism. So in that way we have 8 vertices. So that means how? 4, because 4 is the number of side, multiply with 2. 4 plus 4 or 4 plus 4 is what? Either I can write this as 4 plus 4 vertices or 4 multiply 2. That is the same thing. So that's what we are going to use here. This is 4. In place of 4 we will have n, and n plus n so many times we will write. So sorry, n plus n 2 times it will be written as 2n, right? It's actually n. There we was having 4 and 4 is twice, so 4 multiply 2. Then for the pentagon we have 5, 5 is twice, so 5 multiply with 2. In the same way we have n, so n multiply with 2. So now let us move to the formula of Euler's formula. So f minus e plus v is equals to this n plus 2 minus 3n plus 2n. So this n and n will be 3n. This 3n is as it is with minus sign before, and this 2 will be as it is. So minus 3n plus 3n got subtracted and you are getting 2. And with this we have proved the Euler's formula for right prism also with the polygon basis as a polygon and n sides. Let's move to the